Oh, excuse me. I just barely, like within 30 seconds of starting the call, got over a super um, aggressive hiccuping fit. So if it starts up again, I'm sorry. Um,
Like scandals.
Scandal. What I was going to say though is one of the reasons that I didn't remember when we were talking about it before. Why in the world are you using bounding boxes when you could just simply create a cluster? Um, and One reason is because you can only create a cluster on geometry. On a mesh, well, actually, you can create it on a cluster or on a curve as well. But if you ever had a joint selected, for example, and you wanted to find the center point between a joint or multiple joints and something else, your script will error out because you cannot create a cluster on a joint. But you can find the center of your bounding box regardless of what object you have selected. There are several other object types where that would fail. So um, just an example again, not that you have to do it my way because there are plenty of ways to do things, but that is a case where your script would actually fail.
I seem to remember you saying that the last time
Did
in
I?
class last time
Okay.
too.
Maybe I
It
did.
sounds familiar to me.
Works for me. I am pretty smart like that. I never forget things. I can say that because I know it's not true. Cool. Well,
Well, we'll forget that you said it anyway. So
I know you will. It's already. Wait, what did you say? You already
I,
forgot. You already know. Cool. Okay. Well, we're gonna move on. You should at this point have something similar to about like here, where you have created joints, replaced each of your locators or clusters or whatever you did it with. You should have joints now set up at each of your articulation points. I think I used that word in the assignment description, points of articulation. Um, and when I do say that, again, essentially that just is a point that needs to rotate, a point that needs to move. Okay. Um, we could also say a pivot point, but a point of articulation. Okay. So we have a joint everywhere where we actually have a point on the body or the model that actually needs to move. Let's x-ray our joints here so we can see them. Okay. All right. So now the next process. Did I keep our notes that we wrote down last time? Let's see. Nope, I didn't. Oh, wait, no, that was in whiteboard. Well, maybe you guys don't need me to pull these up. What's our next step?
chaining the joints.
Creating a joint chain?
Yeah.
Okay.
Mirroring the joints, then creating. I don't know. No, you want to
So we
joint
want to do the
chain them,
hierarchy
then you want
first.
to create them, or mirror them. Yeah.
Yeah.
Then you want to orient the joints.
Okay, correct. Oh, here's our. Here we go. Yes, so our joint placement, and you're right, orienting joints. So part of joint placement is that organization. You guys are right. So let's just go through, and as we organize them into hierarchies, we will also take the time to name our joints. And I'm going to use my scripts. We've been through this already last semester, and you should have a scripting tool that will allow you to incrementally name things. And if you don't, that's okay. You'll just go through and name them by hand. We'll just start here at this joint. This will be the spine. We know we're going to duplicate this 2 more times for the hip and the possibly the root joint. We may just put there as well. But for right now, I'm just going to call it the spine. Okay, so we're going to have this joint. I'll pull up the outliner. Oh, you know what? Sorry, you guys. I forgot to ask. Do you have any questions or issues that came up that you need me to answer about last time before I move forward? Okay, I'll take that as a no. So let's keep moving then. So we've got spine 1, 2, and 3. So I'm going to select these in that order, and then I'll use my rename tool, and I'll say spine, little number thing, joint. Okay, and that names them here in the outliner. And then I am going to parent them as well. So spine 3 to spine 2 and spine 2 to spine 1. And then next we'll work our way down the arm. Actually, let's just do the neck and the head really quick while we're here. So this is going to be neck, a 1 joint. Even though there's only one there, I still put a number in case I ever add anything later. And we've got head, a 1 joint. And you don't have to put the number there for a single joint if you don't, that's kind of a preference thing, but I've found experience that sometimes it's helpful to have it there. So this is going to be the left clav, a 1 joint. And I've got arm 1, 2, and 3. So left arm, put in those characters 1, 2, and 3. So let's do a little bit of hierarchy organization here. Let's hide the mesh. So we're going to have the head as a child of the neck. Just hitting P there as a reminder. We're going to have arm 3 is a child of arm 2. 2 is a child of arm 1.
Wait, you said the hotkey is just P?
Just P to parent. Mm-hmm.
Oh, okay, that's nice.
Yeah. And yeah, if I ever do that, if I flip a hotkey and I forget, stop me. I'm more than happy to share it. Oh, I was going to get that on-screen keyboard up here for you. Let me do that really quick. It's called No Board. Where are you? There you are. And load keyboard. Mine. I'll put that right down here. And there we go. We'll see. You guys can let me know if that's going to be helpful or not. This is the mouse, by the way. Left mouse button, right mouse button when they're clicked. Is that you guys see the highlight well enough if you were to go back on the video and?
I think it looks clear.
Okay. Good. Okay. So again, we're going to finish the organization here for the arm. So I'm going to parent the arm 01 to clavicle 01. And we'll work our way through the fingers. So this is 1, 2, 3, and 4. So we'll just say left finger 01. You could call it, like I said, this just comes from working in industry where sometimes you have a character with 10 fingers, sometimes they only have 2. So our scripted solution was just to number the fingers instead of call it like thumb, point, instead of giving them tall man, left finger tall man. In any case, call them whatever you want, but at least for this rig, just follow what I'm doing. So we all have something similar that we can debug together if we need to. So I'm going to say left finger 01, and then we'll say, we'll just call it, no, it's not a digit. We'll call it knuckle. We're in there, right? So this whole finger, the thumb, is going to be finger 01, and then I'm going to have knuckle 1, 2, 3, and 4. Okay. And I'll just organize that finger into its hierarchy really quick by just middle click dragging the child onto the parent. Okay, we'll do the same thing with these fingers. So I've got here, this is just finger 2. And then we'll have knuckle 1, 2, and 3. And we've got finger 3. Finger 4. And we'll just kind of put those into their hierarchy. So finger 3, and then shift select finger 2 and press P. Through all the fingers. And I can take all of these fingers, and actually for right now, I'm just going to leave these separated so that when I orient the wrist, I'm going to have to unparent them anyway when I orient the wrist. So we'll just leave them like that for now. Okay, let's go down to the leg. So we're going to have left leg. So left leg, and we'll number 3. Okay, and then we're actually going to duplicate this joint for the ankle. And we'll wait and do that in a minute because we're going to get still the orientation first. But that means this is going to be foot 1 is here when we duplicate, and then we're going to have foot 2 and foot 3. So left foot joint. And my script allows me to change my starting number. So I'm just going to change this to 2. But, you know, if you had to name them by hand, or this is an opportunity to update, revise your script if you want to be able to change the number you start on. So I've got left foot 2 and 3. And again, I'll just put those into a hierarchy. So I'm kind of keeping the different parts, different parts, different limbs, different, you know, the fingers separated from one another right now because it'll make orientation a little bit easier. One other thing I like to do, this doesn't affect your rig at all, but I like to select all of my joints. Actually, let's just put all of these in a group really quick. Let's call the group skeleton. Okay. And I'm going to expand the whole group. If you remember, if you hold Shift, when you press the plus or the minus next to a node here, it will completely expand it or completely collapse it instead of just one level. And let's just go ahead and select all of the joints in here. I could also have just selected this group. Just in case you don't know this is here, you can do select hierarchy, and that will select everything, every child and grandchild under the node you have selected. Okay, I'll deselect the group itself. And I just want to make a uniform radius for all of my joints. So I'll just set it to 1, just so they all look the same. So when you first build joints, Maya's joint building tool will increase the size of the joint based on how far away it is from the previous joint you created. It doesn't make any sense to me, but that's what it does. So I like to just make them all uniform and change them as needed. Okay, so there we are. Joints are all named and organized as far as we want to take them right now. So I'm going to take a minute and save this as 2. Yes. And then I'll stop for a second and see if you guys have any questions on what just happened. Okay, you feel good about it? You can get this far?
I'm on board.
Cool.
Can you explain the saving process?
Really?
No.
Okay.
I mean, I know it already, but
Okay.
you know.
Okay.
You just asked if we had any questions about what just happened.
Well,
You just
fine.
happened to save it, so you know.
That's why I asked. I had to see if you were being serious or not. I'm happy to show you if you need it. Okay, great.
I think it'd be cool sometimes.
Learn how to save a file?
Yeah.
Okay. Yeah. Oh, what does this say? Is there a reason the skeleton has gaps? Yeah. That's because I assume you're saying, like, why haven't I connected the clavicle to the spine or the fingers to the hand? And that's because it's going to make orientation right now a little bit easier. I could connect them, but I'm just going to have to disconnect them when I go through this process. So, yeah. So, okay, orientation. Does cog get a joint? It can. You know, let's build this with the idea of putting it into a game engine. cog does not have to have a joint. But sometimes I think that's hard conceptually when people are like, I have a control, why don't I have a joint? So we can put a cog in there as well, and then we'll put a root down at the origin. And we'll do that a little bit later. We're just going to copy for the pelvis and also for the cog. We'll just copy this spine joint and reuse that. So good question. Convoluted answer probably. The answer is yeah, if you want to. It doesn't have to. Maybe I should explain why. The cog is simply the parent to both the spine and the hip, right? And I'm talking about the control structure. So when I move the cog, both the spine and the hip should move with it. So as long as you've got that hierarchy set up with the controls, it'll work just fine. But like I said, some people I've noticed, they're like, hey, well, I've got a spine control and a pelvis control, and they both have an associated joint. And I have a cog control, why doesn't it have an associated joint? Well, it doesn't really need it because your controls, right? The cog is controlling the controls that actually control joints. But if it helps conceptually for you to do it, we'll do it. Yeah, refresher on the cog and the root and the pelvis. Yeah, hopefully as we build those will make sense. Yeah, you're fine, Katie. But let me just try to quickly go through what those are. So the pelvis, I mean, you just think of that as the joint and, you know, the bone in your body that allows you to separate, where's my camera? Separate your spine from your hip or your pelvis in the lower half of your body, okay? So that's what the pelvis is, or what it's going to do. The cog control is, think of it as a parent to both the spine and the hip. So without it, I've only got the ability to move them both together. I wouldn't ever be able to take the body and go like this and rotate it as a whole, because they can only move independently from a pivot in the same place. So the cog becomes a parent to both of those controls, and it allows you to rotate the entire rig as one piece from the center, okay? The root is simply the granddaddy for all the joints. And while you don't need this so much in film, you do need it in games because all of the joints have to reference back to a single world location. So generally that root joint sits at the origin as 0, 0, 0. It stays there. It's always right there as 0, 0, 0. Your character is going to go off and animate wherever he wants to, but it stays there at the origin so that again, the rest of the joints use that point as a reference. That's all it is. Good, cool. So let's go through and start orienting. So I'm going to select all of my joints. We need to show our joint orient axis. So we'll do it the old way, and then after that, I'm going to do it my scripted way. So the old way is we bring up our rigging menu, and we go to skeleton, we bring up the orient joint tool, and we toggle local axis visibility. Okay, that's the old way, and you can keep doing it that way if you want to, or if you didn't script a better way. Another way you can do it is if you come over here to the channel box and you go to edit and bring up channel control. Hold on, I thought I turned those back off. There we go. Channel control. You can find here in this list the joint orient X, Y, and Z, and I'm just control selecting those. And the display local axis attribute. So I've control selected all three of those. And then you can hit this move to the left, which is going to make them keyable and visible. Okay, I now have access to those, and I can turn this display local axis to on. And I have all the joints selected. So that showed this channel for every joint I had selected, and then changed that attribute to on for each joint I had selected. Okay, and then obviously if you remember, we scripted this process of showing all of the channels and turning the axis on or off. So if you've got a script to do it, use your script to do it. That's what I'm going to be using from now on. But in case you forgot or if you didn't finish that script, that's how it's done. Okay, so let's think about our spine to start with. So you can see from a side view, his spine is actually leaning back a little bit towards his back. Okay. If I were to orient that with X going straight up the joint chain and Z as his, we've just defined historically that Z is the major bending axis. So I would call that forward and backwards. So this is how that's set up right now. And I can verify that by just rotating on Z, and he's rotating forward. And that's also a positive rotation value. So again, I usually do the main movement, if you can define it, is positive on the Z-axis. Okay, do you guys remember that?
Yes.
Okay, when you say rotate on Z, you mean it's the one that doesn't shift. I don't think I understand what that means. That it doesn't shift. Can you phrase that again another way?
Yeah, I'm probably just being dumb. If I looked at it, I would have thought that it was on Y because Y is forward, but you're saying it's on Z because Z is the one that it pivots on?
Yeah. So think of that Z-axis as a pin that's going right through the spine, right? And so the Z rotation rotates around that pin.
Okay, and Z positive is that it's in the grid square, some of it's positive. How do you know which way?
Great question. So Z positive, it's this simple. When I rotate, let's say I want to rotate my character forward. Okay. I rotate forward. Again, I'm determining that's like the main, I want that to be positive. That's the main axis. Not the main axis, the main direction, I'm sorry. So I rotate in that direction that I want to be positive, and then just go up here and look in the channel box. And if it's a positive number, then we've got it oriented in the correct direction. Visually, if you're looking at the Z-axis, again, that's a pin, and you've got the Y-axis that's coming out in another direction. If you rotate towards that axis, it's going to be a positive rotation.
Gotcha.
So, but again, the easiest way is just rotate on Z and check it. If I wanted it to be the other way, that means I need Z. Z is still going to go through the same way, except it's going to come through backwards on the other side. Basically, it's going to rotate around like this. Right? Going through in the same place, just in an opposite direction, so that Y is facing the opposite side. Positive is the other direction. Does that make sense?
Yeah, thank you.
Okay, you bet. Okay, so I just undid that. So this is it a good policy to have Z positive rotation be curling in and Z negative to be stretching out? Great question. I've done this several different ways depending on what we were doing and how we felt like, we could improve upon a previous iteration. So it's going to change. The policy that I like most is, like I said, yeah, no, actually you described it well. If I'm compressing in, if I'm curling in, I'm going to have everything in the main direction of that rotation. Then that's going to be a positive Z. Yes. So like my arms, as far as the way my body's facing, when I rotate in positive Z, my arms are going to come forward, right, curling towards the front of my body. But my legs, when I compress my knees, for example, they're actually going to go the opposite direction. They're going to go towards the back of my body because they're curling in. That's a great way to describe it. Yeah. And I've done it before where we just do it so all the rotations are going to go in the same direction. So my knees, positive, my arms are bending forward, which means my knees would actually bend backwards. But, positive means towards the front of my body, negative means towards the back of my body. And again, we've used that scheme as well, and it works just fine. So,
sorry, I just want to clarify really fast. So like, let's say you kick a soccer ball, like kicking forward would be Z negative.
Kicking forward would be Z negative, correct.
Okay, thank you.
So it's more just like whatever your project guidebook says. Yep, pretty much. And our project guidebook says exactly that, right? The way it curls in. I'm probably going to use that. That's good. Okay. Now remember, orientation determines not just that main bending axis, right? But how things twist as well as rotate in other directions. So when we're thinking of the hip, when I rotate, let's see if we can picture this. When I rotate on the y-axis, my character's standing straight up right now. If I want him to just bend over directly to the side, your thinking would be rotate on the y-axis. But because his spine is tilted right now, when he rotates, if you can see my hand, he's actually going to rotate like this, so that his head is actually going to start, once you get far enough, it's going to start rotating forward towards his feet. And I don't want that. I want him, even though his spine, the direction of his spine joints is bent, I still want him to bend straight over in that y-axis, right? So that means we're going to use the concept of X is up, but we're going to not necessarily be entirely aligned with the current direction of the joint chain. So we're going to put X straight up in the world so that when he bends in Y, he's going to bend straight down. Okay, same with twisting. Instead of twisting at this skewed angle like this, he's going to twist straight up and down in the world. And there are a few places where I'll use the term relative to world. And this is one of those cases like X, we can clearly see X most closely resembles Y up. It's off, it's slightly askew to Y up, but we're just going to go ahead and match it to Y up. Okay, X to Y up, to allow the joints to bend as you would expect the character to actually animate. And this is one of those weird concepts. I think I lose people here. So if that doesn't make sense, let me know and I'll do my best to try to explain that differently, or have Alexis come up with better vocabulary.
Yeah, maybe just one more time.
Yeah. And you know what, maybe I can demonstrate it better. This character right now, let's make it a little more extreme. Let's say that he's...
Get rid of your grid.
Oh, you bet. Let's say my character's kind of leaning back even more for whatever reason. He's got scoliosis and his spine ends up coming back up like this. Because of the way the joints currently are, they're all pointing directly to each other, and in principle that's correct. Yeah, he seriously needs a chiropractor. If I wanted him to bend, you just picture it yourself, right? If you bend straight over to the side and like touch your ankle, okay? That's what I want him to do with his arms. So when I rotate and Y, you can see he's not bending straight over. He's actually, I know this is really extreme, but he's starting to bend forward because of the rotation of his spine. Okay, does that part make sense?
Yes.
Does that make sense to you, Tori?
Yeah.
So basically what we want to do is fix that. We want him to bend more like this, where he comes straight over the top. Okay. Right there, I just changed my rotation axis to world instead of object. But remember, it's the joint's going to respect the local space, the object space. So instead, what I'm going to do, actually, let's go back to that idea of world space, right? In world space, you can see the axis is aligned with the world. So when I do come over the top, it's a rotation like in the world. In this case, it's the z-axis just because of the way the axes are pointing. But I am rotating straight over the top, regardless of how my joints are angled or rotated. And we need to simulate that with the the joint orientations themselves. Let's go back to object orientation. And maybe I'll just demonstrate it so that it makes sense. What I'm going to do is just unparent these 3 spine joints. Okay, they're all floating on their own. And let's just take a look at their current joint orient. And this is why having those joint orient X, Y, and Z values is important. And when I say, again, let's go back to that idea of relative to the world axis. Let's move this keyboard out of the way really quick. So my world axis is down here in the corner. Okay. When I say relative to this, I'm saying in 90-degree increments. So X might, you know, if I were to rotate this up, X might be pointing up now, which means Y is going to point off to the left and Z would still point in the same direction. We're still going to be at 90-degree increments to the world axis. And we're more concerned about that than the specific direction or orientation of the joint chain. Because remember, that's just visual. That this whole connection thing between the joints, kind of the bone section, that's just visual. That doesn't necessarily mean this is how the joints are going to operate. So what I'm going to do is align the x-axis with the world y-axis. So these are going to be, like I said, in 90-degree increments. My guess is right here, this 90 degrees and this 90 degrees is going to be able to stay for X and Z. But if I reduce this y-axis and just take it down to 0. Oh, hold on a second. I forgot I left rotation in this joint chain because I rotated it to give him a mild form of scoliosis. Okay, let's unparent everything again. Select these 2 joints and I'm going to hit Shift P to unparent. Okay, let's come back down to this joint again. And like I said, these ones are already at 90 degrees, so chances are they're probably really close already. We've just got this little bit of twist here in the joint orient y-axis, so I'm just going to reset that to 0. And now this X joint is, or X orientation is pointing straight up. Y is pointing straight forward, and Z is pointing in this other axis. So if we look at the world orientation again, it's not the same as world orientation, but it is relative to it. It's set up at some 90-degree increments to that world rotation. Okay, and I'm going to finish getting through this really quick, and then if you guys have any questions about what the heck just happened, then I'll go ahead and ask them. So we'll do the same thing here. I'm just going to align this to world. I could just delete or 0 out that Y value. You can see it's snapped to the world axis. And you remember the tip joint never orients correctly. So if I actually just use the exact same values here, so I've got 90, 0, 90 for my joint orient X, Y, and Z. So I'll just type those in, 90, 0, and 90. Okay. Independently, all 3 of these joints now are, X is still up, but they're all relative to the world. They're at 90-degree increments to the world. So now if I were to, again, parent these into a hierarchy, right, you can see that X does not point exactly to that next joint. But that's okay. That's the orientation I'm going for. So I'm going to rotate this down now. And you can see, well, let's just rotate the root. This is in local orientation. You can see he's going to bend straight over in that axis now, rather than bending towards the front. Okay. And again, I know this is kind of a weird, bizarre thing because we've always been orienting directly to the next joint, directly to the next joint. And when we get into IK systems, that's imperative. You have to point directly to the next joint. But for other places like this, we can play with that a little bit. And yeah, Alexis, okay, so you just brought up that exact point. You guys might remember we had, I'm pretty sure we did this in the first class. Did you guys rig the big excavator, that machine shovel thing?
Yes.
And you'll remember we had, let's draw this really quick. Like the shovel went up like this and it came back down, and then this was connected to like a seat area that pivoted like here. But then the treads themselves, there was something like the middle of the treads was here, right? So if we were to orient everything according to how the joints faced, they would have been something like this. Which means when you tried to rotate the cab here, instead of rotating, it should rotate like this, right? But because my orientation is like that, when you orient around that axis, it would have rotated at this funny angle. It would have broken. Every time you rotated it, it would have crashed down into the treads. So if you guys remember, I know this is a while back, what we actually ended up doing was, even though the joint chain pointed, the position of the joints, or that indicator of a hierarchy, pointed in this direction, like that, we still had to reorient the joint so that it was like this, so that you could properly rotate the cab. You guys remember that?
Yeah.
Yep.
It's the same concept here. And you know, with that spine, it wasn't very angled. It's probably not going to make a huge difference for this specific case. But understanding that is important, because we'll run into that in more cases later on. So yes, you do not, X does not 100% always have to point directly to its child joint. Typically it will, but if there is a special case, a specific reason why you need to alter that, you can do it. Unless you're using an IK system, in which case you just can't. Okay. And typically on a character, there are just a few places on the body where I do that, and we'll walk through them here as we go through it. Everything you learned was a lie. Like, for example, you might think I'm taking a drink of water. Nope. It's a cup full of Cheetos. Nice try. Just as good. Okay.
This isn't the first time that I've been taught lies for a year and then had to learn something completely different.
Well, the question you have to ask yourself is, did I teach you a lie? Or did you not understand what we were doing the first time?
Fair enough.
Yeah. And maybe I didn't teach it well enough the first time. Hopefully it makes sense the
Well,
second
I
time.
understand it.
Cool.
And I understand that it wasn't completely a lie, but it's still a lie. Same with the other subject that this happened in.
I'm still confused on how we got a cup of Cheetos confused with water.
It was a magic trick. It was my lie.
Our brain is mush. Don't question
I'm
anything.
sorry. I didn't
Clayton
mean to
just lies
confuse
to
you.
us all the time.
Now you're probably thinking I'm sipping Cheetos through a straw.
Nah, that's booze.
Nope, it's booze. Oh, goodness.
When you first said water, I was like, nah, that's vodka instead.
Oh, not yet. Not yet.
Haven't
Okay.
reached that point in the semester yet.
No, we've still got a little while to go. Okay, here we go. So we're going to move on from the spine. Like I mentioned, we're going to do this again a few more times. So, you know, let's keep going. The concept might be a little shaky right now, and hopefully we can clear it up a little as we keep going. So, let's go to the arm. Okay, I'm going to actually ignore the clavicle for right now. So let's just unparent it. We'll come back to the clavicle. And let's work on the arm. So the arm is going to have an IK system in it. So again, the idea of orientation from, you know, X pointing to the next joint is 100% imperative. You have to get it right. So let's just start here at the root, orient this, and see what we get. So I've got my rigging tool set up. We'll go to skeleton and orient joint. Bring up the options for that. And let's remember how this tool works. Okay, we have to select the primary axis. This is the direction that's going to be pointing at the next joint. So that's pretty much always set to X. And then these two work together. The secondary axis, you know what, maybe this is a better way to explain this. This primary axis is super easy. We're just saying point this axis at the child joint. Okay. The secondary axis, they work together. We're going to say point this axis in this direction. Okay. So, and this is the world. So if I said y, I'm saying put the y-axis, point it in the, well, positive y direction. Okay. Again, I obviously cannot have the x-axis pointing at a joint and have it pointing up in the world. So it will never let you have both of those axes be the same. But so that we can see something happen here. Let's say I want the z-axis pointing up in the y direction. Okay. It's pointing to the child, and then z is pointing up in the world y. I'm going to turn off orient children for now, though I usually will have that on. Here we go. I'll hit apply. Let's undo that so you can see what happened, right? X is pointing down, Z is pointing up in the world Y direction. Okay, if I said I want Y pointing in the, let's say, the positive Z direction, right? Z is character forward here, so that's off to the screen left. I'll hit apply, right? And that's flips it over so that Y is pointing the other direction. So essentially it's taking that x-axis and pointing it in the right direction, and then it's, oh, there's my camera. And then it's just twisting those other two axes. It's twisting the y-axis so that it can point to either the z or the y-axis in the direction I specify. Okay. So we have to think again, how do I want this arm to work when my arm moves forward? We'll just think about the elbow. When the elbow curls in, moves forward like that, I want that to be a positive rotation. So in order to do that, and think of it as a pin, I need the pin to go through my arm, either from the top or from the bottom, but it's going to go through my arm. And then which direction that goes, top or the bottom, that's going to determine if this is a positive or a negative rotation coming towards the front of the body. Okay. Right here, I just kind of here. Let's do both ways here. So Z right now, that's kind of right. Z should be pointing down or up through the through that joint, the shoulder joint. So I'm actually going to take, let's do this again. I'm going to say X is my primary, and I want Z pointing in the positive Y direction, so straight up in the world. We'll hit apply. And then for this one, let's say same thing, except we want Z pointing down. All right, so we can see both of them. We know we need that pin to go up or down through the Y axis so that we're rotating like that forward, right? Both of these joints are going to rotate in the proper direction on the Z axis. And now it's just a matter of determining which one is positive and which one is negative. So again, I said visually you can tell this by when you rotate the joint on the Z axis towards the Y axis, that's going to be the positive rotation. And I can verify that right here by rotating towards Y, and I'm there at positive 39 degrees. Okay. Same thing here. If I take this joint and rotate on Z, and I'm rotating the bone section here towards the Y axis, right, that is positive. So this is the one that I want. I want Z coming up from the bottom rather than from the top. Does that make sense?
Yeah.
Yeah.
Okay. I should say, does it not make sense? Speak up if it doesn't make sense.
Let us try it, and then on Friday.
Go for it.
if we have
Okay.
questions.
Good idea. Okay,
I
so
thank you for explaining that again.
yeah,
This, yeah, that.
this guy here.
Because before I was like a little confused on the secondary axis world orientation. I didn't know how that related.
Oh, okay. That make more sense that way?
Yeah.
Good. Okay. Good. So let's do the same thing here. So I'm just going to start at the shoulder this time. I'm going to orient all children, and we'll just hit apply. Okay. And now I should be able to, oh, remember that the tip joint, this tool never works for the tip joint. So I'll just select the tip joint, and let's just clear out my X, Y, and Z joint orient channels. Okay. I should show you this too while we're here. You can do that if you say orient joint to world and then run this tool. That will zero out your X, Y, and Z values as well. It's not orienting it to the world as much as it's just zeroing out those channels and orienting it to its parent. Okay, or you can, like I said, you can just go through and select these and hit 0. I typically don't have this tool up, so that's my workflow. Okay.
But if it was the base joint, the topmost parent joint, it would orient to the world.
Exactly. Yep.
Okay.
Yep. Okay, so these joint chains in the limbs where we have IK systems, they have to be absolutely 100% straight. So we can already see right now there's a little bit of bend in this elbow. I'm sorry. Let me go back. They have to be 100% straight other than in the Z-axis. You can have a little bit of like elbow bend or knee bend. But that bend, you can't have, I know my bone can actually do this, but if you have, if your bone this way maybe sits up a little bit higher or a little bit lower, so you have a weird bend in your joint like that, or in your joint chain, that won't work. Your system will solve incorrectly. So as long as your arm is straight from this view, if you were to look down from the top and the arm was a little bit bent at the elbow, that's okay. As long as that hinge is still in line with everything else. So we're going to have to do a little bit of fixing to this. So let's just hit save again, make sure we don't lose anything. And we've been going for 50 minutes, so let me give you a breather for a second. Chew on it for a sec. Should the shoulder have the same Z-axis, the Z as the elbow? The way I'm envisioning it is the clavicle would be responsible for rotating forward and backwards, so not the shoulder itself. I'll keep the orientation from the clavicle all the way through the arm essentially the same. It's kind of like the spine. The clavicle we're going to do relative to the world, but really Z is going to be the same all the way through the arm. And so that's so you can select any part of the arm, clavicle as well, and you can rotate everything in one direction. That makes sense. It's for your animators. You get into your curves, you don't want, the forward axis for your arms going like this, but then for your clavicle, it's actually the Z axis. You don't want your Z axis to do something completely different. So that's why we do it. Okay. I'll just get another drink of water. Crunchy water. I don't know. Do little breathers help? They always say teach for 20 minutes and give them a break, but.
I love breathing because my mind can rest for 2 seconds.
Oh, good. Okay. I just finished Mandalorian.
It was fantastic, right?
It was really good.
No spoilers.
Oh, never mind. Let's do a different one. I've been watching Hannah on Amazon.
Meh.
I like it okay. Except I didn't like when Darth Vader showed up. That part was crazy. That tie-in. I'm just kidding. It didn't happen, Steve.
Clayton, can you tell me you've watched The Mandalorian without telling me you've watched The Mandalorian?
His name is Grogu.
Yeah, I was going to say that, but then I don't want to ruin it. My kids told me that. I was like, shut up!
Wow.
Don't tell me anything! I get crazy about spoilers. So as soon as I know someone hasn't seen it, I'm not talking about it anymore. I just watched Barbie and the 12 Dancing Princesses. It's pretty good.
Classic. That's a
Hey, no
throwback.
spoilers on that. I'm still watching.
Whoa.
Wait, there's 12?
Oh, yeah.
Dang
And they're
it.
all mocapped in perfect unison. It's amazing.
It's almost like they just recycled the model over and over.
Maybe, but I doubt it. They wouldn't do that. So good.
They're not going to know.
They're gonna know.
How would they know?
You change the color of the dresses, and then they're completely different people.
Totally different. Okay, are your brains rested? You ready to go? Perfect. Let's do it.
Let's do it.
Okay, so, as far as alignment goes, we pretty much have two options. We either move the position of the joints so that they're in alignment, or, well, we're doing the same thing no matter what. So what I'm saying there is I could go in and actually like shift a joint. We'll do it in a more precise way. Like I could say, I like where this is going, so I've just got to align it here. Number one, or I can take this joint and reset its joint orient values to its parent, ensuring that it's in alignment with its previous joint, which also you can see it does shift the position of the child joint, but I'm not translating. In that case, I'm by hand, I'm resetting my joint orients to make sure that it's correct. Okay. So we'll go through this technique. I think I showed you guys last semester. That does a little bit of both. Okay. And the idea here, let's pull up the whiteboard. The idea here is right now, I'm going to make this a little bit extreme. We've got joints that are out of alignment this way, and we need them to be straight across like that. So the technique we're going to use here is we're going to unparent. Oh, I should say right now we've got our axes are pointing directly at their children joints like that. Okay, and again, we need our orientation to come straight across. So our solution here, what we're going to do is unparent these joints, like so. And then we're going to parent this wrist joint or the child joint directly to that shoulder. So we're bypassing the joint in the middle. And then we're going to orient this joint directly to the child. So we know we have a straight line. Okay, right from there down to the next joint. And at the same time, we could go ahead and orient this as well. We could just reset all of our transformations so we know these are both going to be oriented in the same direction. Okay. Once the shoulder joint has been oriented, we will reintroduce the elbow joint into the hierarchy. If you remember, all of the transformations of a child joint or a child node are relative to the parent. So now this is going to show, it'll show some rotation, probably some joint orient rotation. It definitely will, because this is pointing down, which is different than this orientation. But it's also going to show its translation away from this straight line. Okay, so it may be translated in several different axes. We'll find out. So if we zero out there's two axes that have to be zeroed out. Its position up or down this line, as long as it's in the exact same orientation here as the shoulder, it doesn't matter. It could be here, it could be here. It really doesn't matter as long as it's in that same line of orientation. But as far as how high it is, or this way off of the line, we can't have that happen. Okay, that's where the problem's going to be. So we're going to use the transformation in this case. We'll orient everything properly at the shoulder, and then reintroduce the elbow joint into the hierarchy. And we will get rid, by zeroing out its transformation values, it will bring it in line with the rest of this orientation. And we can reintroduce it into the proper hierarchy. Oopsie, like so. And the wrist as well, because everything should be in a straight line at this point. Okay, conceptually, are you guys okay with that?
Makes sense to me.
Okay.
Yep.
From the top down, so this is like a front view, right? From the top down, remember, It's going to be okay. We don't have to be exactly 100% straight here. If our joint is back a little bit like this, we're going to be okay to introduce a little bit of bend in the elbow. Okay, but we're going to start with this technique here. And if we need to put bend in the elbow, then we're already, as long as we have everything in the same orientation, it's going to be easy for us to just push this back a little bit. And that will force this only to rotate in the z-axis. So then our orientation will still be pointing from one joint to the other, but this will force that orientation to a single axis, to that single z-axis. Okay, and that's probably what will happen with this character. So let's take a peek. We're going to start by unparenting our elbow joint, or joint 2, so shift P, and then we're going to parent joint 3 directly to joint 1, or the shoulder. So I'll just hit P. Maybe let's show the geometry for this so we make sure that we're still kind of hitting the right landmarks. Or maybe I'll show it in a minute. Let's bring that back. Okay, so we've set that parenting structure up correctly. Now we need to orient the shoulder joint. I want that to point in a straight line directly to the wrist. So I can just select the shoulder, and our settings here in the orient joint tool are already the way we want them, right? X is pointing down, the joint chain, and the z-axis is pointing down in the negative y-axis. Okay, and you saw there was a little bit of a shift there. I'm just undoing and redoing that really quick. And you'll see the numbers change in your channel box as well. There is a slight shift. Okay, so the shoulder joint is now pointing, it's oriented directly to the wrist. Let's go ahead and just zero out our wrist joint as well, so we know that that's oriented in the exact same direction. So I now have a straight line of orientation between these two joints. Okay, and now let's just unparent joint 3, or the wrist joint. And actually, we'll leave it in there just for visual sake, so you guys can kind of hopefully. Let's reintroduce the elbow joint into the joint chain. So I select joint 2 and then joint 1, I'll hit P. And right now I'm completely ignoring my joint orient values. Okay, I'm more concerned with my translation values at this point. So my X value is going to determine where I am this way on that line of orientation between the shoulder and the wrist. Okay, the X and the Y, I need to get in alignment before I can fidget with the X. So I'm actually just going to take the Y and the Z channels, and I'm just going to zero them out. Let's try that again. Them out. Okay. And you can see now that the center of that joint is exactly in the center of the, I don't know if I've defined this out loud, but this section connecting the two joints is typically called a bone. We don't really use that in Maya, but that's typically what it's called. You can see that that's centered inside of that bone, okay, which is what we want. Excuse me. The x-axis, like I said, determines how, oh boy, excuse me again, sorry. The x-axis determines how far away, it should be still directly on that same line, how far away it is from the shoulder. But that only actually works if my orientation is the same as the shoulder. So right now my values are off. I'm going to have to zero out my rotation values on the elbow. Otherwise, you'll see, I'll move this back. You can barely see it, but I'm off a little bit from the center point. That's because my orientation is just a little bit different. So let's just zero out our orientation on the elbow joint. Okay, and now this joint is exactly in line with this orientation between the elbow and the wrist. Okay, so at this point, like I said, if there needed to be a little bit of bend in the elbow, because this is oriented the same, it's all in line, I can move this back a little bit, I can translate it back a little bit. And when I reorient the shoulder, it's only going to rotate in Z to match where that position is. Okay, and same with this, as it rotates back to the wrist, the elbow is only going to rotate in Z to match that position. But in order to make that work, you have to be in alignment with that joint chain and with the same orientation, okay? You okay with that? You're not okay with that?
It might take some application trial and error to nail down, but yes.
Okay.
I think I get it, but I may rewatch the video.
Yes.
So I'm curious. So you said that you can shift it back and it can have rotation in the Z.
Yeah.
Is the issue when you have rotation in both the Z and the Y? Or what exactly is the problem?
So if you remember an IK system, it's responsible for rotating the elbow, right? And what happens is when you first create the IK system, it determines a kind of like it determines how it bends, essentially. Let's just say that. It determines how it bends. And if, how do I describe this? If you've got a triangle, so if you've got a perfect triangle, we're looking at it, so this is from the top. Okay, if we're looking at that same triangle, let's turn it so that we're looking directly from the front like this, right? So you're going to have 3 joints that look like this. And let's say they're in perfect alignment. Okay, as this elbow bends, it's going to be able to make a really simple rotation back towards the shoulder that will stay in alignment here. But if your joints, if they're not straight like this, instead from the front view, they look something like this. And your orientation, say this orientation points in this direction, and this orientation points in this direction, and this orientation points in whatever, another direction, doesn't matter. Remember, it will, how do I describe this? If there's an axis going through each of these, this is the axis it can bend on. So how do you get this elbow to bend perfectly back to the shoulder if you don't have an axis that allows it to do that? Does that make sense? Instead, this is going to want to bend like this. And so your arm is going to bend and bring the elbow more like up to here, instead of bringing it to the shoulder. Does that kind of make sense?
Yeah, I think so. So the real issue with it is when you bring 2 numbers into the equation, when you're like bending on the Z and the Y,
right,
as opposed to just one of the axes.
Right. And it has to be whatever we've determined as that main point going through the elbow. That's the only axis that can be bent.
Gotcha.
As far as orientation goes. That's it.
Okay, that makes sense.
Hey, that's a happy little face. Oh, he's kind of cute. He's my new character. Okay. Yeah. He's got a little soul patch going on too. Aww. I'm going to give him a name. Okay. And this, again, this is one of those things that you guys have already said it. Doing it and seeing why it's wrong usually helps you understand why you have to do it the right way. So I don't know, maybe you guys have run into that where I know some of you have, where you bent the arm and it does this really funny thing too, where the closer it gets to where the shoulder matches up, your elbow, if you guys can see me, your elbow will often go like this. It'll start to take off in a funny direction. Instead of just coming straight across like you'd expect, it goes like, what?
That's why it does it?
That's why it does it. Yep, that's the reason. And you're animating and you're like, why won't you just behave? And that's
just I'm very familiar with that one.
Yep. So maybe that motivates you to say, oh, I don't understand this, but I got to figure it out. So, all right, let's just finish up this arm really quick. Let's show the skin. You know, you can see where that elbow is placed right now. It's actually close enough to the center of his elbow that I'm fine with where it is placed. It was up a little bit higher before. And, you know, if I want to keep my wrist where it is, if I wanted my elbow to come up a little higher, my only option really is to bring my shoulder joint up a little higher. You can see that where that bone is, right? It's got to be somewhere in line with that bone. Which, again, that's okay. You can kind of fudge around with these after you've put them in. And I actually kind of like that. I might bring this up a little bit higher. Didn't notice how far down that shoulder joint was. I'm going to bring this up a little bit. I'm just holding D, by the way. If you hold D on a joint, if you don't hold D and you move it, it will move the whole chain. If you hold D, it will just move a single joint. So I'm going to have to kind of go through this process again, which is okay. I'm going to bring that up just a little bit higher. Let's do this again. So I'll unparent the elbow, right? And I've got the wrist parented directly to the shoulder. Let's go ahead and orient joint. So it's the shoulder's pointing directly down to the wrist. Let's zero out our transformations on the wrist so that it matches the shoulder currently. And we're going to reintroduce the elbow. So we'll parent that to the shoulder. And his transformations now are in relation to the parent. So we'll go ahead and zero out the joint orient. So it's the same for now. And I'm going to delete or zero out my Y and my Z values. Okay, so it is in line. Right, my X value now matches up. Should match up. Wrong there. Hold on a sec, let me make sure I got this. Yeah, that's right. That's why I've got my world transformations on. It's like something's not right here. Now when I slide on X, that will match up exactly to the position of the shoulder, right? It's got the exact same orientation and it's only been translated in X along the line of that joint. So again, let's take a look at my elbow here. I'm happy with where that is. I'm happy with where the shoulder and the wrist are. So like I said, if I wanted to introduce the little band, I could just push this back a little bit. And maybe I will just so you can see. No, I'm not. We'll do that on another. We'll do that on the knee, actually. We have to do it on the knee. I'll just leave it here perfectly in line with the rest of this arm. Okay, which means now I can reparent the wrist directly to the elbow and the wrist too, because these are all now the exact same orientation and the only difference is that translate X value, right? These should all be zeroed out for both the elbow and the shoulder, or the elbow and the wrist. The shoulder, because it's oriented in relation to the world, it's going to have all kinds of values in it. And that's okay. All right. So that arm is done. That's oriented. If we take a look at the clavicle, we have kind of the same issue we do with the spine. Sometimes the clavicle sits maybe a little bit more forward on the body, like that, or a little bit more backwards on the body, depending on the center of mass for the chest and where the arm rests. But you don't want the behavior, like when he rotates forward, you don't want the arms to like go up or in some strange direction. So this is another case where we're going to orient this with X moving towards the shoulder joint, but in relation to the world axis, right? So on this one, I'll just do this one by hand. I'm just going to zero out all of the joint orient values for starters. Okay, that actually almost gets me all the way there. I've got the x-axis is pointing in the direction I want it to, towards the arm, but I need the z-axis to be pointing down and y, similar to the rest of the arm. So, you know, I could come in here and actually directly change the joint orient values and just rotate it down 90 degrees. Sometimes those behave a little bit funny, so sometimes I'll just take and use the actual rotate tool. I'll just rotate it down, go to my channel box and say 90 degrees, and then freeze just the rotations. So where's that freeze? rotation, and that sends the rotation values down to the joint orient values. Okay, so again, the same basic idea, though it's not pointing exactly to the shoulder joint. It's pointing in the direction of the shoulder joint, but at 90 degrees relative to the world axis. Okay, so if I were to parent the arm back into the clavicle now, and we selected all of these joints and rotated them in positive Z, right? Everything will rotate forward, and in negative X, everything will rotate backwards. Okay, so that arm, that part of it is done. Anything you need me to repeat on that, or are you okay if we just do the same process again on the leg? That'll be our repetition. Let's do it on the leg. Oh, sorry, go ahead.
Oh, yeah, let's move to the leg.
Okay, let's do it. You can see his leg really bends backwards. He's got his pelvis kind of thrusted forward, but that's okay. Before we move on, there's one thing we do need to make sure we take care of. You remember we have, select the elbow joint. Bring up the attribute editor. You remember we have this value called preferred angle. When you have a joint chain like this and it's perfectly straight, the IK solver doesn't know which way you actually want the arm to bend. Sometimes it just picks one random direction, and sometimes it just won't bend at all. So we need to set this preferred axis to say we prefer that it bends in this direction. So we've set this up so that we want it to bend this way. That's a positive Z rotation. So on that elbow joint, just come into the preferred angle, and we'll just add a value. I just usually use +5. I found really low values don't work well, and really big values don't work well, but 5 seems to be a sweet spot that works just fine. So once you add that there, the arm will bend in the right direction. If you forget to add that and you put an IK system on and it doesn't work the way you expect it to, just delete the IK system, add your preferred angle numbers in there, and then just recreate it, and it should work. Right. Look at the leg. We're going to go through the exact same process on the leg. So let's take the ankle joint. We're going to parent that directly to the hip joint. And then let's take the knee joint here and unparent it for now. Okay, so we need to determine how the leg works. So we want, when we rotate in positive Z, we want the knee to bend backwards. So we'll just be consistent with the rest of the leg and rotate backwards. So this is actually probably pretty close to what it needs to be. Here's a Z rotation to the back, and you can see that that is a positive Z rotation. So X is going to point down the joint. Let's take a look at our world axis here. I'm going to have Z that is twisted. We're going to have Z pointing. Look here at my world axis. I want it coming out to the right. That's world X, positive. So X points down, and then my Z axis, I want to point in the direction over here, which is positive X. I'll hit apply. And again, just verify that's what you want. We'll rotate on positive Z, and that's rotating towards the back. That's what I want. Okay, so go ahead and zero out the ankle. So that will take on the exact same orientation as the parent joint. Now we've got our line of orientation here between the two. Now we will introduce the knee joint, this hierarchy. So I'm parenting the knee joint. You can see that's off quite a bit from that straight line. His knee was actually kind of facing backwards. If I would have put an IK system in as is, his knees would have bent backwards like an ostrich. Never watched the show, but I'm pretty sure that's not how he walks around. Oh, did you guys ever see that old Charlie Sheen movie called Arrival? Nah, that's before your time.
It's not that old, is it?
Have you seen it?
I've seen it before.
I don't know. It's probably like mid-90s.
Yeah, okay. Yeah, I'm pretty old too.
You remember how the guys bent their knees backwards?
Yeah.
Oh,
Yeah, it's creepy.
Sounds
yeah.
familiar, but I don't know.
Ah, that's a good little flick. Dumb little alien science fiction movie. Okay, sorry. Here we go. Let's get back to this. So we just introduced the joint chain, the knee into the joint chain of the rest of the leg. So let's start by zeroing out our orientation values. So we're oriented the same as the hip. And you can see that my joint's offline for that orientation line quite a bit. It's in the center of the knee, right? But my orientation line isn't. So again, your options are you either bring it away from that center line or you adjust something else. Like I could bring this hip in towards his body a little bit more so that I'm closer to the center from this view. With a knee joint like this, a knee joint bends in one axis, right? It should only bend in Z. That being said, this knee joint honestly could be clear over here. As long as it's only bending in that one axis, it's not going to make a big difference. So sliding it over that little bit, I'm okay with that. So I'm going to go into my translate channels and I'm just going to zero out both Y and Z. Right, and that will put it perfectly in plane with my both the hip and the ankle. Okay. Joint orients are zeroed out. I only have a translate X value because I've moved that far away from the parent. Okay. Now let's say in this case, I know his knees aren't bent, but we're going to just do a kind of a slightly different case here. Let's say that we did want his knees bent just a little bit. Once we're at this point, everything is oriented properly. Everything's in alignment with each other. Now I can, let's get back to my object orientation here. Okay. I am free to move this joint anywhere I want along the x-axis. Obviously, I want it where the knee is, but if I ever needed to slide it, I can do that at any time. That's not going to mess anything up. I don't even have to like reset my orientation. It's already in alignment. But if I ever did need to change it, let's take a look at our edge loops again and make sure we're still centered. We're good there, okay? But let's say we had a little bit of a bend in his knee, okay? Again, once you're aligned, never, ever, ever move in this axis, okay? In this case, it's Z. It might not be the Z axis, but I can't break the leg. If I'm moving it forward, which is going to introduce a little bit of bend in the knee or bend in the elbow, that's okay, but I can never move it side to side like this, or I completely blow up my orientation. So
you're supposed to sweep the leg, not break it.
The leg. So I'm going to introduce a little bit of bend into the knee. Okay, so I'm just going to bring this forward a little bit. Okay, and I can the X and in this case the Y-axis, I can fidget around with those and it's not going to break anything. Okay, I am messing up the orientation, but we're going to reorient and it will work fine. Okay, because again, we are still in alignment. You can see the Z-axis is like a pin going directly through that joint. Because I'm in alignment with that curve right now, by moving it forward, all I'm doing is forcing the Z joint to rotate a little bit. Okay, I can introduce that bend into the knee. So that being said, what I do now, if that's where I want my knee to be, let's go ahead and unparent that ankle joint. I can reparent it here to the knee, right? So I get my hierarchy set up properly. This orientation in the hip is still pointing straight down to the ankle. And the knee is pointing straight down, but now it's right. They've still got the previous orientation, but since I moved the translation, I need to reorient these. So we'll just select these again, same orientation. I'll just hit apply. Okay, and I did something wrong. What did I do wrong here? Oh, you know what it is? It's because my place this joint perfectly in that positive X direction without introducing a little bit of twist because of the angle of the joints right now. But a pretty easy fix. You can see my joints, I have these like 0.00, it's introduced these really, really tiny values. just after you've oriented, just go ahead and clear those out. Just set those both to 0. You couldn't even see them in the viewport. There's like so very little change. And down in the ankle, just go ahead and 0 that joint out as well. Okay. So, you know, what your root joint does when you hit orient joint, that's whatever it gives you back, typically you're going to be fine. It's getting this elbow joint correct. So again, as long as you only have translate Z values and you can have orient Z values, then you'll be fine. Your rig should work just fine. Down in your ankle, you should only have translate Z values, no orient values at all. Okay. Let's see what comments we had here. Returning to the concept of plus Z curl and negative Z curl, stretch it out with the knee. You need to have its Z be the inverse of the hip. Yeah, this is one of those where you want to keep the entire leg the same. So I'm using the elbow and the knee, that middle joint as my starting point. Like I said, if you wanted to have everything rotate forward, great, or everything rotate back, that's fine. But you don't want, like when you select the leg joints, think about being an animator. If you select all 3 of the leg joints and you want to like have your character run, in my mind anyway, I think I want to rotate, like I want the leg to come back. I want to rotate everything in the same axis. I don't want to have to select one control and rotate it positive and then the knee control negative and then the ankle control in a different direction. Just do them all in the same direction, so to make your animation easier to animate and your animation curves very consistent. You can look at the curves and know exactly what's happening. When we start flip-flopping, it gets really, really difficult to work with. Okay. You guys have any questions? I know you got to do it, but any questions on the difference there when I added a little bend to the knee?
Made sense to me.
Okay, good. Let's come. You get it? Okay, cool. All right, let's take a look at the neck and the head really quick. The neck and the head, I'm going to treat it exactly the same as the spine. When I bend the neck to the side, right now his neck's kind of at an angle. Where is it? Angling forward. And the head would be angling forward as well. I don't want that. I don't want the head to rotate down or forward or twist at a weird angle. I want it to be as if it's in world orientation. So a twist should twist like there's a y-axis going right up through his head. Right? Same with the neck. So for both of these joints, I'm just going to take that idea of relative to the world with X pointing up. So let's start with, actually, let's just unparent both of them. I'm going to 0 out all of their joint orient values, and we'll just do this by hand. So we know for sure that we want X to be pointing up. So I'll rotate that 90 degrees in that direction. And then the Z-axis, I'm just going to be consistent with what we had with the spine. So the spine was when Z is positive, he's bending forward. So we'll just do the same thing with the head and the neck, that they will rotate forward. So I'm going to need to, basically I can match the spine orientation. I'm going to rotate this direction 90 degrees as well. Okay. And that's it. So I need to freeze my rotation so that we'll bake that down to my joint orient values. And I'll redo my hierarchy here. Okay, and that's it. Again, it doesn't matter that they're a little bit forward, this neck's going to rotate directly down to his side. All right. Save. And tell you what, let's work on the hip really quick, or the pelvis joint. Like I said before, I'm just going to duplicate the spine joint. Okay, when you duplicate a joint or any node, it also duplicates all of its children. So I'm going to just select spine 2 and delete it. I only need the one joint. Let's just rename it while we're here. We'll call this pelvis, one joint. And let's just increase the radius a little bit so we can see that there's something else there. And this is another one of those orientation questions. If I rotated the spine in Z positive, it's going to rotate forward like this. If I rotate the hip independently of the Z independently of the, the pelvis independently of the spine, what do we expect to happen, right? Do we expect it to rotate towards the back of the body, kind of consistent as if they were both rotating about the same point, or would you expect it as its independent system to rotate kind of crunch towards the front of the body as well? Again, in my experience, we've just kind of done this sort of thing. So it's kind of everything curls towards the front, okay? Which means we're going to need to change the orientation of this a little bit. And maybe I will introduce or add leg 01 as a child just so we can see what's happening. If I rotate right now in positive Z, right, my legs are bending towards the back of the body. So I want to invert that. I want it to go the other direction. So let's unparent the leg really quick so that we can do this orientation. So there's the pelvis. And basically, I need the Z-axis to point in the opposite direction. So we'll just say for that joint, well, let's just do it by hand because I don't have any children joints to orient towards. So this should be pointing like so. Actually, you know what? I need the X-axis to point down first. That should be pointing down towards, not exactly to my leg joints, but in the direction of the leg joints, right? You know what? I'm just going to start this from scratch. Zero out the rotation and zero out the joint orient axis. So X is going to, am I on the right joint? Yeah. X is going to rotate down. I'm sorry. Over here. Let's bring that forward like this. 90, that's negative 90 degrees. And then we'll rotate it down so it's pointing down in the world. So again, everything's going to be in 90-degree increments. So you'll see it. Sometimes it'll be like 80, rotate it as close as you can. You'll get like 80s and 90s and 180s and 270s. And you just, once you know you're close, you should be able to just type the numbers in. So X is pointing down right now. Let me hide the spine. And this may actually be exactly what we need. Let's just freeze the rotation and reintroduce the leg. And let's rotate forward, and that is a positive rotation. Okay. Does that make sense how I got there with this joint?
Why not keep the X pointing the same direction, like pointing up the spine?
Mostly just so we're consistent, because the leg, you know, this is the whole bottom half of the body, the legs, everything else, X is pointing down those joint chains. And we really do have we have a split in the two hierarchies here. They're going to be completely different hierarchies. So that's the idea, is just X is consistently pointing in the same relative direction.
Gotcha.
Yeah. You absolutely could do it the other way if you wanted to. If you wanted to. But again, there are reasons to do this. Your animation curves are going to be more consistent, easier to read. So I say you can do it the other way, but there are reasons. All right, we go till 4:40, right?
Yep.
About 10 more minutes.
Jace.
Perfect. Okay, so that pelvis is done. That is ready to go. Let's come down and take a look at the foot now. So we are going to duplicate leg 3, this ankle joint. So I'll just duplicate, and I'm going to unparent it. And let's just increase the size again. I'll just change the radius to 2. So I know I have another joint there on top of it. And let's call this one foot 1 joint. That should be consistent with the naming of these 2 joints, and it is. And let's just build this whole hierarchy up. So foot 2 should be a child of foot 1. Let's just go ahead and hide the pelvis group so that it's not in our way. So same concept here. We're going to have X pointing down to the next joint, and we want the Z-axis being our main rotation axis. So what's the main rotation axis of a foot? What do you guys think? How would you do this?
Like toe towards knee would be your main
So
rotation.
kind of like bending up towards the knee?
Yeah, that would be your positive.
Okay.
If we want to keep it consistent with the leg, we would do it the other way.
Right. So both options are completely valid, but I'm going to lean on the side that Nathan said, and that's because when you bend at the ankle or at the foot, right now we've got the whole leg. Negative Z is going to rotate the whole leg back. Just for consistency's sake, we should do the same thing with the foot and the like the ankle and the ball and the toe as well. So again, that's not wrong, Steve. It's not wrong at all. But just for consistency's sake, we'll do it the other way. So, so in that case, let's unhide the pelvis again. We can just take a look again. So we've got X going down, and we've got Z is coming out in the positive X direction, world X direction. Okay. So let's select the ankle or foot 01. We want X pointing down, and we want Z pointing in the positive X axis, which is how I've got this set. And we'll hit go. And let's take a look. We are going to put some, we're going to build, we didn't do reverse IK systems in the foot, right? Does that concept sound familiar? Okay. So we're going to be introducing a new concept to our feet. And we add kind of some pseudo IK systems into our foot, but the importance of orientation is a little bit differently for these. We don't have to be nearly as strict.
You want to add that with the 6 minutes remaining in class?
The reverse foot?
No.
Yeah, right. No way. Good idea. No way. Not going to happen.
Okay.
So what ends up happening, you guys, is these three joints. No, I can't really describe this until we get into that later. What I typically will do, maybe just this is the short version, is unless there's some weird foot that doesn't allow us to do this, I like to have my orientation from, how do I say this correctly? I like to have the ankle is going to be oriented directly down to wherever the ball joint is, okay? And that's the same with the shoulder, right? Wherever you put the shoulder, it doesn't really matter. But I like to have the foot, like from the top down, whenever possible, a straight line towards the toes. If the foot's angled out in one direction, that's fine. But as long as you have from the ankle down to the tip of the toe, wherever you decide that to be, have it be in a straight line. So just now I oriented from the ankle. So if I take a look here at the ball, you can see I've got a little bit of Z-axis, orient axis, because that's this direction. And I want to keep that because there has to be this bend coming back up in the ball. But it's also introduced a little bit of side to side and a little bit of twist with the other two orient axes. I'm just going to zero those out. I don't need those, don't want those. So I should only have a translate X and an orient Z, so similar to the elbow. And then I just bring this toe. When we set these out, I did this anyway. I just came straight out from this the ball joint. So I can just go ahead and reset my joint orients on this, and I only have a translate X. So again, this is a straight line. I introduce a little bit of rotation to bring the foot back up, and then it points straight out towards the toe horizontally. Okay, and like I said, this one isn't as strict, but I find I get pretty consistent results if I treat it kind of like an elbow. All right, clear enough? Clear as mud?
Heck yeah.
Great. So we'll stop there if there's any other questions. Let's save this really quick. And then next time we'll finish off doing the fingers and then start building the FK rig. So what questions do you have?
So should we still only do one side?
Yeah.
Okay.
Yeah, you'll just do the one side until, I mean, once you get to this point, you're ready to mirror it over. But don't mirror it until you have everything in its hierarchy named correctly and with this orientation, or else you're just going to have to redo it on the other side.
Sounds good.
Yeah. So obviously we still have quite a bit to do here on the fingers, so don't mirror those over yet. But we meet next on Monday, right? It's Wednesday. Yeah. You should have your rig at the exact same place on Monday. Oh, thanks. You know what? I'm glad you brought that up. So Friday we're doing our lab days, so that gives you a chance to get all caught up. I can lecture if you want me to, but I'm just going to be available to you. It's a chance for you to work and get caught up and review lecture if it's needed.
You need to save your
I'm not
voice.
planning on it. I just got the all clear to bring in a TA for our rigging classes. She's a former student of mine. She's awesome. Her name's Sarah. She knows her stuff really well. She's been doing some commercial work and stuff, but she's going to come in and TA. I'm going to try to get her to be around. Wait, do you guys have a class right after this?
No.
Okay.
No,
what I'm gonna,
Yeah, you're our last class.
Oh, awesome. I'm going to have her be around maybe for the last bit of our class and then for the next hour or two following each of our classes. And then she'll be there for the labs as well. So like I said, she knows her stuff. She can help you out with anything you need. I just want you guys to have another resource.
Does she answer Teams and Discord?
Answer what?
Quick? Does she answer Teams and Discord pretty quick?
She will. I mean, during those times, basically, she'll be blocked out for you guys. Basically, as a tutor specifically just for you guys.
Okay.
So we still have to get the paperwork figured out, but she will be a fantastic resource for you.
That would be good.
So next week, I'm thinking we'll have everything in place by next week. So again, Friday, that's your chance to get all caught up. I am available if you need to reach out to me. That's fine. Otherwise, plan on having your rig at least up to this point by Monday. We'll move on with fingers and start building the FK systems. Okay.
Thanks, Clayton.
Thanks, guys. Have a great weekend in 4 days, 3 days.
Thank you.
Will you hold on the line? Or give me
Yeah.
a call when you're done.
Yeah, I'll give you a call. Yeah, that's fine. Okay, see y'all.